All right, let's dive into something we all rely on every single day, but maybe don't think about too much: the invisible security architecture that keeps our data safe online. We're talking about distributed security. I mean, really think about it. When you're using an app that's running on hundreds, maybe thousands of servers all over the world, how does it actually know that it's you? And maybe even more importantly, once it knows it's you, how does it decide what you're allowed to see and what you're allowed to do? While it turns out that the entire massive foundation of modern digital security, from your banking app to your social media, it all boils down to answering just two fundamental questions. And the order really matters. First up is authentication. This is the system asking, who are you? You can think of this like a security guard sitting in a big office building lobby. Their only job is to check your ID and verify you are who you say you are. That's it. Then, after that's settled, authorization kicks in. This part asks, okay, now that we know who you are, what are you actually allowed to do here? This is your electronic key card. It won't open every door in the building, only the specific ones you have permission to enter. And getting this distinction right, it's not just important, it's everything. Understanding this clean separation between identity and permission is really the secret to building secure systems that can actually scale up. Let's be real, the challenges these systems face are enormous. They have to verify identity and check permissions millions of times a second, all without slowing anything down. The secret to pulling this off is to treat identity and permission as two completely separate problems to be solved. So let's tackle that first big question. Who are you? The modern toolkit for verifying identity is pretty much built around a standard called OAuth and the use of these things called digital tokens. You've definitely seen OAuth in action. It's that sign in with Google or log in with Facebook button you see everywhere. Think of it this way. You would never give a contractor the master key to your entire house. That's kind of like your password. No way. Instead, you'd give them a temporary guest pass that only works for the kitchen and bathroom for a few hours. That's exactly what OAuth does for your data. So here's a quick look at how that little dance works. You tell an app you want to log in. That app then sends you over to a trusted identity provider like Google. After you securely log in there and approve the request, Google sends the app back a special digital key, an access token. Now, this token proves who you are, but the crucial part is the app never actually sees your password. And that right there is why OAuth is the gold standard. It creates one central, super secure hub for managing your identity. And the tokens it hands out are temporary and have a limited scope, which dramatically, and I mean dramatically, reduces the risk if one ever gets compromised. Okay, that brings us to the tokens themselves. This is basically the digital version of your Smart ID badge. Instead of you having to type in your password over and over again, the client application just flashes this token with every single request it makes. It's a constant, lightweight way of proving its identity. A really common type of token you'll see is the JSON Web Token, or JWT. And it's not some magic black box, it's actually just a structured piece of data with three parts. You have the header, which just defines what it is. Then you have the payload. That's the good stuff, with your user ID, when the token expires, things like that. And finally, you have the signature, which is the cryptographic proof that nobody has tampered with it. This simple, self-contained structure enables an incredibly powerful idea: stateless authentication. Because the token itself contains all the necessary info, the server doesn't have to remember anything about your session in its own memory. This stateless approach is the secret sauce that allows systems to scale massively. Any server can handle any request just by looking at the token. Okay, so we figured out who the user is. Check. Now we have to answer that second question. What are they actually allowed to do? This is authorization, and there are two main ways folks approach this. The first, and definitely most straightforward method, is an access control list, or an ACL. The best way to think about this is to just imagine a list taped to a supply closet door that says, Jane Doe can enter, John Smith cannot. It is a direct, one-to-one mapping of a user to a resource. Simple as that. And as you can see right here, ACLs are super simple and explicit. For this thing called file X, user A can read it and user B can write to it. It's incredibly easy to understand, and honestly, it works perfectly for simple systems where permissions don't change very often. But what if your rules are more complex? What if it depends on your job title or the time of day? Well, that's where rule engines come in. Instead of a simple list tied to a resource, a rule engine acts like a central brain for security decisions. It evaluates flexible policies that can look at all kinds of attributes, not just who you are. For example, A policy might say something like this: allow access, but only if the user's role is admin, and the resource type is a report, and the current time is before 6 p.m. This much more dynamic approach is called attribute-based access control, or ABAC, and it's incredibly powerful. So this presents us with a really clear trade-off, right? ACLs are simple and fast, but they become an absolute tangled mess to manage once you have a lot of users and resources. Rule engines, on the other hand, are powerful and flexible, letting you manage everything centrally. But they do add a bit more complexity and can be a little bit slower. So, which one do you pick? How do you decide? Well, it is all about matching the tool to the specific job you have. So let's bring it all together and figure out how to make that choice. Here's the key takeaway, the rule of thumb you should remember. If your permission model's pretty straightforward, like users can edit their own documents, ACLs are fantastic. But if you have complex business rules, different user roles, and big enterprise requirements, you're going to need the power of a policy engine. And you see these exact patterns everywhere out in the real world. A giant SaaS platform like Salesforce, you better believe they're using OAuth, JWTs, and a very sophisticated rule engine to handle permissions. An e-commerce site? They'll likely use tokens for customer shopping carts, but a really simple ACL to control which employees can update a product description. It's always about using the right tool for the specific task at hand. And that brings us right back to that core decision. By separating authentication from authorization, and by understanding the trade-off between simple lists and powerful engines, you can now really start to think like a security architect. The path you choose will define your system's security, its flexibility, and its ability to scale. So for your next big idea, which will it be?